Hello, students, and how are you today? Well, we're starting to get close to St. Patrick's Day where everybody can pretend they're Irish. And I thought it'd be fun to have these green do nows and just get into the spirit of things. So we're going to start. I guess I could use green today. For our do now, we're going to complete the do now. It's Thursday. We're going to have a thankful Thursday today and just be at thankfulness. Enjoy the moment, be thankful for something right here, right now. So, our objective will be to add and subtract monomials. And our essential question we're going to ask what kind of monomials can be added together and what cannot change when we add and subtract monomials. So, for our assignment, we're going to complete the do now, complete the work page. It's just one work page, my bad. So that means I have to make it a heart because you're awesome. There we go. I just put a heart there, no mistake. Complete the work page on monomials, complete the exit ticket, and show your work to the teacher. If you don't finish, you can just finish it later and send me a photo, okay? So, Pi Day is coming. It's going to be awesome. Everybody's going to have fun, and it's all about fun. Please, guys, don't think of it as pressure. Think of a way to have fun. You just do your best. So, we do have an exit ticket, and today we're going to do a fill in the blank. So, we'll get to that at the end of the lesson. So, first of all, as promised, is our Thankful Thursday conversation. So here's the question. What is one thing you are grateful for that helps you to be a better learner? Now, it might be your technology, might be the tools you use to work with. Some of you have all the colored pens and pretty pencils. It might be your work ethic. That means that your ability to get started. I have so many of you that get into this lesson and start it before I even start the class. And then you're so proud to show me what you've done. Maybe that's something you're thankful for, is that you have that desire to do so well. Maybe you're just thankful for a silent place to learn. I want you to stop right now. Be thankful for something in this very moment, something right now. So, and write about it right here. So let's go through our problems after you've had your thankful moment. Maybe I am thankful for my students. Okay, and I'm going to actually draw a little shamrock. I think I can still draw a shamrock. There we go. I'm thankful for my students. And that's you. And I want you to point to yourself and I want you to say, Mrs. Gold is thankful for me. So let's get into these monomials. This prefix, this part of this word, means one. And I was talking with one of my beautiful students just this afternoon, and she said, "Oh, I can't pronounce that word." And I laughed. It's a hard word to pronounce. And I told her about this. Mono means one, and I've asked her if she ever rode the monorail anywhere, and she said, "Sure, at Disney." And the monorail has one rail, so that's another use of that word, that prefix mono that means one. So a monomial is a number or a variable or a combination of numbers and variables. So a number, it can be a variable, and it can be a combination of numbers and variables. But wait, Mrs. Gold, you said just one. Well, together it makes one expression. So -7 is a monomial. 2x is a monomial. 1/4 xy is a monomial. X to the 6th power is a monomial. And negative j to the 5th power is a monomial. Those are all monomials. But super important here, monomials with the same variables and exponents are like terms. So in order to add or subtract monomials, we must simply combine like terms. And I know we've done a little bit of this, and some of you have gotten really good at it. So remember, you're not going to change anything. Do not change the variables. Remember, the variables are the letters, and don't change any exponents. Those, like this. This is an exponent. This is an exponent. So if they have like terms, we can add them. If they don't have like terms, we cannot combine them. So they must be like. So we have 4x and 5x, and those are like terms. They're both x terms. So 4x and 5x, we simply add, and that would be 9x. Negative 12ab minus 2ab, well, we have ab in both of those. Those are like terms. So just think negative 12 minus 2 is negative 14. And that's negative 14ab. So try the next four. Let's try 3, 4, 5, and 6, and let's see how you do. Okay, did you pause the video and try them on your own? Let's see, we have 7m squared minus 9m squared. So we have like terms. 7 minus 9 is negative 2. And again, we don't change the variable. We do not change the exponent. Okay, number 4, did you fall for this trick? You have to remember, when we subtract a negative, it's like multiplying this quantity of negative 8k. It's like multiplying it by 8 with an invisible 1 right here. So negative 8 minus a negative 8 has the effect of making this positive. So that would be negative 8k plus 8k, which is, of course, going to be 0. Cancels itself out there. Number 5, we have negative 3 r squared s. R to the second power, we call that r squared, plus 11r squared s. Do we have like terms? Yes. So basically, negative 3 plus 11. And negative 3 plus 11 is 8. So that would be 8r squared s. And number 10, we have 10 PQR plus PQR. Students, we have an invisible 1 here. If we don't have a variable, we can assume the variable is 1. So that would be 10 plus 1, which of course equals 11. So that would be 11 PQR. And let's see if you can try. We've got some subtraction here. So why don't you try, this is a good time to pause the video and try number 7 and 8. Okay, I hope you tried it on your own. 15ab to the third power minus negative 15ab to the third power. So here we have that subtracting a negative, which makes them positive. So what we have is like terms, ab to the third power. We have 15 plus 15, which is 30. And then we have our ab to the third power. Did you get that? If you didn't, just make sure you think about it a few minutes. Now we have 10x to the fifth, y to the second, minus 14x to the fifth, y to the second. So basically, we have like terms, so we're looking at 10 minus 14. So we're going to have a negative answer, and our answer would be negative 4. So the solution would be negative 4, x to the fifth, y to the second power. We've simply combined those like terms. Now, the rest of these problems, 9 through 16, we've got multiple terms. So we're going to combine them. We have 4 monomials we're going to add up here, and number of 9. So let's just remember, combine like terms. Let's write that down here so we don't forget. Combine like terms. Do not change the exponents. Do not change the variables. If they may be combined, great. If they can't be, they stay as they are. So here we have negative 5m minus 2n plus n, that's an invisible 1 there, minus 3m. We can combine negative 5m and negative 3m, so that negative 5 minus 3 is negative 8. So we've got negative 8m. Now we have negative 2n plus 1n. So that's negative 2 plus 1, which is negative 1. So that would be minus 1n, but that 1 is invisible. We just write n. And when we write these, students, we like to write them in ABC order, alphabetical order. So we would have the m before the n term. Now remember, we are only combining like terms here for number 10. So we have 8xy minus 2x plus 3y minus 5xy plus 8x. Okay, it's a mouthful. Let's see what we can put together. We have 8xy minus 5xy. Well, 8 minus 5 is 3. So that's 3xy. All right, let's move on. Let's do the x terms. So we've got negative 2x plus 8x. So negative 2 plus 8 equals 6. So that's a positive 6. So that would be plus 6x. And let's see what's left. It looks like we have 3y term there, and it's positive 3y. There's nothing else to combine. So that's our final answer right there. Okay. So why don't you try 11 and 12? Let's see how you do with that. Pause the video and then come back and let's do 11 and 12 together. Okay, so number 11, we have 7k squared minus k plus 12k squared plus 4k. We can only combine like terms, and we're not going to change variables or exponents. So 7k squared, and here I have a plus 12k squared. So 7 plus 12 equals 19. So that will be 19k squared. And now let's look at the k terms. I have negative k, and that's a negative invisible 1, plus 4k. So that's negative 1 plus 4, which is 3. So that would be a positive 3k. And there's our final answer. So number 12, let's see what we have here. We've got an exponent of 3. So we've got negative r to the third, and remember that's an invisible 1r to the third, minus 2r squared, minus 8r squared, plus 5r to the third. So what we've got with our r to the third terms is negative 1 plus 5, which would equal 4. So we have 4r to the third. And let's change our color. And how about these r squared terms? We have negative 2 minus 8, and both of those are r squared. So it's negative 2 minus 8, which equals negative 10. So that would be minus 10r squared. Okay, 13 and 14, we'll do those now. So we have 8c to the second power, or c squared we can call it, minus 4cd plus 3 squared minus cd, and there's an invisible 1 there. So let's start with our, we can start with our, let's start with our 8c squared. So we have 8c squared plus 3c squared, and that would be 8 plus 3, which equals, oh, I just made a mistake. Let me go back. I think I misread it. My eyes must be tired. Let's go back and get that right. C squared, CD, D squared, CD. Okay, let's start with the C squared. That's the only term we have. We don't have any other C squared, so we're done with that. Okay, let's change the color. Now we're going to look at the CD terms. We have -4, then we have negative invisible 1. So that would be -4 minus 1, which is -5. So that would be minus 5CD. And let's find another color. We have 3D squared and nothing to combine it with, so we just write that, 3D squared. Sorry about that. Okay, let's look at number 14. Now, be very careful. What do we got here? A to the second power, B to the second power, plus 9AB minus 12AB plus 3A to the second power, B to the second power. So I think we're going to look at those A to the second power, B to the second power terms. And there's this one here, and there's this one here. Now we have an invisible 1 here. So it's 1 plus 3, which equals 4. So we've got 4 with A squared, B squared. Now let's change our color so we get this straight. On the AB terms, we have positive 9 plus 9AB minus 12AB. So that would be 9 minus 12, which equals -3. So that would be minus 3AB. And number 15, a little word problem here. Find the sum of 8m to the third n to the second power and -3 to the third n to the second power. I'm going to write over in this space over here. I'm going to write that out. So it's 8m to the third n to the second power plus -3m to the third n to the second power. And we can rewrite that like this, 8m to the third n to the second power minus 3m to the third n to the second power. And that would be 8 minus 3, which equals 5. So that would be 5m to the third n to the second power. And then our last problem for today, subtract -4xy from 2xy. Be very careful. This is a turnaround phrase. So if we're subtracting -4 from 2xy, the 2xy is first, minus 4xy. Do we have like terms? Yes, xy. So this is 2 minus 4, which would equal a -2. So our final answer will be -2xy. Boy, colorful lesson today. I hope you enjoyed it. Let's go back to and I am thankful for you. Let's go back to our exit ticket. So we have a fill in the blank. Okay, when I blank and blank, let's find another color that'll show up a little better. When I add and subtract monomials, I must be careful not to change the variables and exponents. The variables, those letters, and those exponents. So, great job today. Got time for one more shamrock. Let's see if I can get a little better every time I draw it. And thank you for your attention today. Thank you for your hard work. Thank you for showing me your work. And I look forward to seeing you in class. Remember, with practice, you'll be great.